arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is a constant. Let's denote the difference as D. So, the first term is equal to A. So, the second term is equal to A plus D. The third term is equal to the second term plus D. That is A plus D equal to A plus 2D. The fourth term is equal to the third term plus D, which is equal to A plus 2D plus D equal to A plus 3D. Okay, let's look at the coefficient of D in each of the term here. So we have the first term, the second term, the third term, and the fourth term. In the first term, there is no D, so the coefficient of D in the first term is 0. The coefficient of D in the second term is 1. The coefficient of D in the third term is 2. And the coefficient of D in the fourth term is 3. So, if we have the nth term, the coefficient of D should be n minus 1. So, this is the general term or the nth term of an arithmetic series. T sub n equal to A plus n minus 1 D. Arithmetic series is the sum of arithmetic sequence. The first term plus the second term plus the third term plus up to the nth term. Or we can denote it as S sub n. So the symbol S sub n is the sum of the first n terms. In arithmetic sequence, Sn is equal to A, the first term, plus the second term A plus D, plus the third term A plus 2D, plus up to the nth term, that is A plus n minus 1D. Let's say this is equation 1. Okay, we can write this series in descending order. That means we start from the nth term. If we start from the nth term, we have to subtract by D to get the next term. So the next term will be Tn minus D plus Tn minus 2D plus Tn minus n minus 1D. Let's say this is equation 2. If we add these two equation 1 plus equation 2, we will get on the left side 2s sub n. On the right side, we will add the terms one by one. So if we add the first term, we will have A plus Tn. For the second term, when we add it, we have also A plus Tn. Because A plus D plus Tn minus D, D minus D will be 0. So we are left with A plus Tn. For the third term, we add it together. So we will have also A plus Tn. So we will do this up to the nth term. For the last term here, when we add it together, we will also have a plus tn. So in this sequence we have n number of terms. So that means here we have n times a plus t sub n. So that means Sn is equal to n over 2 multiplied by a plus t sub n. So this is the formula of the sum of the nth term. If we substitute t sub n by using a plus n minus 1d, so we will have n over 2 a plus n minus 1d, which is equal to n over 2 2a plus n minus 1d, which is another version of Sn for arithmetic sequence. Geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. Let's denote common ratio as R. So the first term is A. The second term will be A times R. The third term will be the second term times R. That is AR times R, which is equal to AR squared. The fourth term will be the third term times R, which is equal to AR squared times R equal to AR cubed. Okay, as we can see here, in the first term we have A. The second term AR. The third term AR squared. And the fourth term is AR cubed. Let's look at the power of R in each term. For the first term, the power of R is 0. R to the power of 0 is 1. For the second term, the power of R is 1. For the third term, the power of R is 2. And the fourth term, the power of R is 3. So therefore, if you have the nth term, the power of R will be n minus 1. So this is the general term or the nth term of geometric sequence. Geometric series is the sum of geometric sequence. Let's say we want to have the sum of the first n terms, that is S sub n. So S sub n is equal to the first term plus the second term plus the third term plus ... up to the n minus 1 term plus the nth term. And we can write it down as A, that is the first term, A times R, the second term, A times R squared for the third term. For the n minus 1 term, it will be A R to the power of n minus 2. And for the last term, it will be A to the power of A times R to the power of n minus 1. So let's say this is equation 1. If we multiply equation 1 with R, we will have R sub n equal to A times R is AR. AR times R will be AR squared. And so on. Till we get here times R, we will have A R to the power of n minus 1. And for the last term, we will have A R to the power of n. Let's say this is equation 2. If we subtract equation 1 by equation 2, we will have on the left side Sn minus r as sub n equal to, on the right side, ar minus ar will be 0. Ar squared minus ar squared will be 0. Ar to the power of n minus 1 minus ar to the power of n minus 1 will be 0. So what is left in this equation is a and ar to the power of n. So the right side will be a minus ar to the power of n. On both sides of equation, we can factor out. On the left side, we can factor out Sn. So we have 1 minus r. On the right side, we can factor out a. So we have 1 minus r to the power of n. So Sn is equal to a times 1 minus r to the power of n over 1 minus r, where r cannot be equal to 1. Because if r equal to 1, this series will be undefined. If absolute value of r is less than 1, so let's say if we have r equal to 1 over 2. Okay, 1 over 2 raised to the power of large number, let's say 1000. It will be approaching 0. So this is a special case for geometric series. If absolute value of r is less than 1, we can find the sum to infinity, where when n approaches infinity, r to the power of n will approach 0. So therefore, S infinity is equal to a times 1 minus 0 over 1 minus r, which is equal to a over 1 minus r. This is called the sum to infinity. Let's look at example 8. Find the fifth term and the nth term for the geometric sequence 4, negative 12, 36, negative 108, and so on. So here, if you want to find the fifth term and the nth term, we need to know what is a and what is r. So from the given sequence, we know that a is equal to 4, and the common ratio r is equal to negative 12, that is the second term, divided by the first term, that is 4, which is equal to negative 3. So therefore, the fifth term will be ar to the power of n minus 1, that is ar to the power of 4, which is equal to 4 times negative 3 raised to the power of 4, which is 3 to 4. The nth term will be ar to the power of n minus 1, which is equal to 4 times negative 3 raised to the power of n minus 1. You can leave the answer like this. You can use index rule, which is equal to 4 times negative 3 to the power of n divided by negative 3 to the power of 1, which is equal to negative 4 over 3 times negative 3 to the power of n. Example 9. The nth term of a sequence is given by t sub n equal to 3 over 4 raised to the power of n minus 1. A. Show that the sequence is a geometric sequence, and B. Which term of the sequence is 243 over 1024. When we want to show that a sequence is a geometric sequence, we have to show it by using general term. So, first, we have to find 3 consecutive terms in general form. So, t sub n minus 1, t sub n, and t sub n plus 1 is 3 consecutive terms. So, we already know what is tn. So, now we are going to find t sub n minus 1. T sub n minus 1 is 3 over 4. We will substitute n with n minus 1 here. So we have n minus 1 minus 1, which is equal to 3 over 4 raised to the power of n minus 2. T sub n plus 1 is equal to 3 over 4 n plus 1 minus 1, which is equal to 3 over 4 to the power of n. So, if it is a geometric sequence, it will have a common ratio. So, here we are going to find the ratio of the consecutive term. So, the first ratio is t sub n over t sub n minus 1, which is equal to 3 over 4 to the power of n minus 1 divided by 3 over 4 to the power of n minus 2. By using index law, we will have 3 over 4 raised to the power of n minus 1 minus n minus 2, which is equal to 3 over 4 to the power of 1. For the second ratio, we can get it by dividing t sub n plus 1 by t sub n, which is equal to 3 over 4 to the power of n divided by 3 over 4 to the power of n minus 1. This is equal to 3 over 4 n minus 1, which is 3 over 4. As we can see here, we have the same ratio, that is 3 over 4. So we can conclude the sequence is a geometric sequence because it has a common ratio 3 over 4. Question B. Which term of the sequence is 243 over 1024? So the question asks us to find which term equal to 243 over 1024. So that means to answer question B, we need to use the general term Tn. Tn is equal to A, r to the power of n minus 1 equal to 243 over 1024. Okay, to find the value of n, we need to know what is A and what is r. A is the first term. The first term is equal to 3 over 4 raised to the power of 1 minus 1. 3 over 4 to the power of 0 is equal to 1. R is 3 over 4. This value we get from the previous solution here. Okay, so we substitute this value into the equation. We will have 1 times 3 over 4 raised to the power of n minus 1 equal to 343 over 1024. So on the left side, we have 3 over 4 raised to the power of n minus 1. On the right side, we can write down 343 as 3 to the power of 5. 1024 is 4 to the power of 5, which is equal to 3 over 4 raised to the power of 5. So here we have exponential form with the same base, that is 3 over 4. So we can compare the index n minus 1 equal to 5. So we have n equal to 6. So the sixth term is equal to 343 over 1024.